You can only use the regression equation when these three conditions are met. Number one, the scatter plot has to suggest that there is a linear relationship. You look at it and you go, yep, that looks pretty linear to me. Number two, that value of R lies outside the critical values, and that confirms what your gut was saying in number one. These should either both be yes or both be no. This just confirms what your eyeballs were telling you right here. And then number three, the data do not go much beyond the scope of the available sample data. When I said our pizza and Subway fare fell in the years 1960 to 2003, you wouldn't want to use that same line to make a prediction about the year 2500. It's just too far out there. So that's another thing you need to check. If any one of those three conditions are met, you can't use your regression equation. Is the calculator going to give you one anyway? Yes. Is MyMathLab going to ask for it anyway? Yes. But you're the only one who can go, oh, here it is, but I'm not going to use it. And when I can't use the regression equation, my very best prediction, and it may not be a good prediction, it's just the best I have, is going to be the mean of the sample Y's. And I added this. You might want to type this on your notes because I probably added it after you printed your notes. From a long time ago, how do we find the mean of something we have saved in a list? We press second and stat to access our list menu. We move the cursor over twice to have, it said math, didn't it? That's what's highlighted if you move your cursor over twice. And then number 7 says standard deviation. And you have to tell the calculator what list you want the standard deviation of. I don't mean standard deviation, I meant mean. Yeah, mean. Number 7 is mean. Do you want the mean of your X's or the mean of your Y's? Mean of the Y's, and in which list did you put your Y's? List 2, so make sure you tell the calculator, I want the mean of list 2. Shouldn't what? Okay. Look what Chelsea's saying here. I don't want the standard deviation. I want the mean. That's number 3, not number 7. I keep trying to improve my slides, but along with improvements, there are going to be typos, and y'all are my guinea pigs on this improvement. Thanks for helping me fix it. All right. There are a lot of flowcharts in the book that I don't like. They're just so darn confusing, but I think this one's pretty good. This sums up how to tell if you have to make a prediction, and that's exactly what the problem will say. Predict the Y value. If you see the directions predict the Y value, then you have to decide, can I use my regression equation, or am I going to have to use the mean of the sample Y's? The way that you make this decision is checking these 3 things. Look at the scatter plot and see if it looks like a line would fit it pretty well. Look at your R value. You could put right there, if there's a linear correlation, absolute value of R is greater than the critical value. Then yes, there is a linear correlation. And you're not trying to make a prediction beyond the data that you have, or very far beyond the data you have. If you answer yes to all 3 of these things, then take your X, plug it into the regression equation. But if you answer no to any one of those things, And really, these two should always be the same. Looks like a line is a line. Not is a line, but looks like a line fits it pretty well. Sure enough, a line does fit it pretty well or not. If you can't use your regression equation, the mean of the sample wise is what you have to use. All right. This is going so much better than yesterday. I have 3 examples. I know we can get at least 2 of them done, and that's probably enough to get you going on the homework. The homework that's actually from R.2 only asks you for R and the critical values from the table, and then either yes or no, is there a linear relationship? Because that's really all that's covered in 10.2. In 10.3, it will go on to ask questions about, okay, what's the equation of the regression line? Is it a good fit? Use it to predict something else. So I kind of broke my examples up the same way. Number 24, you have data on the price of TVs and the quality score. Maybe that's, it says from Consumer Reports. And we're trying to answer the question, does there appear to be a linear relationship between the price of a TV and its quality score from Consumer Reports? My gut says, I hope there is. I hope that the more you pay, the better you get. But as a consumer, I know that's not always true. Let's see for this data. Because it takes a few minutes, we're not, well, actually, you are going to have to type it in. Okay, go ahead and type the prices in list 1 and the scores in list 2. Jamie, go back to your y equals menu and clear out that other equation you typed. And then do zoom 9. And let me lay your scatter plot up here for everybody to see if it looks reasonable. Yeah, okay. To get this graph that Jamie has, you'll need to clear out the other equation you typed in. Go back to y equals and press clear. And then press zoom and choose number 9, which said stat plot, I think. Zoom number 9. If you're not getting a graph like that, come see me. Does it look like a line would fit that data very well? My gut says no, not very well at all. I could put one maybe right here that would have 3 above and 3 below, but some of the points would be pretty far from it. So, thank you, ma'am. What that tells me is the scatter plot doesn't suggest that there's a linear relationship. Let's see if our value of R confirms that. Remember where to find R? Linear regression t-test, stat, tests, and then scroll down to the letter F. Everything should already be set up correctly. You just go down to calculate, press enter. And somebody give me that R value to 3 decimal places. 0.543, is anybody second that? Is that very close to +1 or -1? Not really. But how do we determine how close is close enough? Well, if you tell me to use a significance level of 0.05, and how many data points do I have? 8. Look back at the screen where I have that table from A5. Look under the 0.05 column for significance level and the 8 ordered pairs row. I think that's right, 0.707. And really we understand that that means positive 0.707 is a critical point and negative 0.707 is another critical point. Would our R value lie between negative 0.7, positive 0.7, or outside? It would lie between. And does that mean there is a linear relationship or is not a linear? Not. That confirms what we thought when we saw the scatter plot. So would our results suggest that the more you pay, the better TV you get? Not necessarily. There doesn't appear to be a linear relationship. The problems from 10.2, that's all you have to do. Look at it, get the R value, compare it to critical values, and then say yes or no and make a conclusion. But the problems from 10.3 will go further. They will ask you for other things. It may say, predict the quality score of a rear projection television which costs $5,000. When I see those words, or that word predict, that's when I think, I better check these things on my flow chart. I better check that these are true before I use my regression equation. If I can't use my regression equation, what am I going to use? The mean of the sample Y's. Okay, so let's see if those conditions are met. Was the $5,000 within the same range of prices on our sample data? No, it's pretty far outside. Will my calculator give me a regression equation regardless? Yes, it will. If I ask, it'll give it to me and it won't tell me, hey, don't use this. Go ahead and look on linear regression t-test and give me the value of A rounded to 3 decimal places. Three decimal places. 43.178? 48.178. Okay. Round to whatever my stat lab asks you to round to. Plus round B to 3 decimal places for me. I'm sorry, I didn't hear you. 0.008. Don't forget your X. Otherwise, your calculator will just say, oh, I can add those two numbers. All right, the calculator gave us a regression equation. Can we use it to make this prediction? No, we've already decided it's not a good equation. We answered the questions up here. It doesn't look like a line. The R value's not close to -1 or +1. My prediction I'm trying to make is not even close to the sample data that I have. So, yay, here it is, but don't use it. And if I can't use that, what must I use instead? The mean of the sample Y's you already have those Y values saved in list 2. So say second stat, choose number 3, and tell the calculator, I want you to find me the mean of the sample Y's. Give me just to the nearest dollar. $66? No, oh, that's a credit score. I mean, a quality score, 66. I thought that was dollars for a second. It didn't make sense. But the best prediction we have, and is it likely to be a very good prediction? Not really. It's just the best we have, is that a $5,000 TV would have a quality score of 66. Now, the most common reason that people miss these predictions in 10.3 is because they get a regression equation and they use it every single time, regardless of whether it's good or not. Your calculator will give you the A and the B for that regression equation, but it can't tell you use it or don't use it. You have to figure that out based on the scatter plot and the R, and whether or not you're trying to predict something that's close to your other values. If yes, then go ahead and plug the 5,000 right here. But if not, then you're going to have to use the mean of the sample wise instead.